are the two main things that impact them. So that's why we focus on the value proposition and the blueprint of the business model canvas. And then when we design, later we design prototype and now we design visualization, we want to make them easy to understand and easy to use, easy to learn. Otherwise, people are going to resist them. Now, the more advanced theory that fixes some of the missing factors here is also similar. So it says people will use your technology if it improves their performance. So performance expectancy is how much I expect this solution to improve my performance. That could be efficiency, could be entertainment, could be financial performance, whatever it may be. It's basically the same as usefulness. And the second one is effort, which is the same as ease of use. How much effort do I expect to put to learn and to use the solution? If it's too much effort, I'm gonna most probably resist it, right? And we see this every day, right? So that's why Tableau give us product keys for free for students. Why do they give us the product key, not companies? Because you guys are going into the workforce, and they know if you use Tableau, learn it. Next time you have an option to use a visualization tool, you're going to pick the one you already learned and use because you want to reduce your effort, right? You want to spend less effort because you already learned it. You don't want to invest in new effort. Same thing with giving discounts to students for Apple, for example, laptops, because they want you to get used to the Apple ecosystem. Once you get into the ecosystem, most likely you're not going to switch because people want to reduce effort expectancy. Once they learn something and use it, they're unlikely to switch. Some may, but the majority don't. So that's psychology. That's a proven psychology. So the same thing you want to apply when you build your designs in prototypes or in your also visualizations that you share with colleagues, teammates, bosses, etc. You don't want them to learn your design language every single time, where your design is completely different and you use different locations for filters and different types of actions and colors and fonts, where it becomes something new to learn every single time. Then there's social influence, of course. People around you influence what you use. If most people around you, your friend group, in our network use Apple products, you're most likely to be an Apple user, for example, and etc. All right, so we spoke benefits is basically value proposition. When we design, we want to design visualizations that are easy to learn and to use in the long term. And I use this in theory in multiple papers. Okay, quickly, a few things to avoid, then we take a break and go through hands-on. So just be careful with changing your starting access. All visualization tools allow you to change your starting access from 0 to, for example, the minimum or a different number. Sometimes when you do this, you unintentionally could make the gap between two bars big or bigger than it actually is, which may communicate a different story. Because here, if you look at it, this is 39 versus 35. Actually, the difference is not that huge. But when you start with a different starting point, you may communicate something else, that the gap is wider. Also, if you look at a lot of the big companies' reports that they publish publicly, or if you look at scientific journal papers, you will rarely if any, see um, tables with heavy borders like this. So you're unlikely to see something like this. And the reason is when you're presenting information or data, so table is also an example of visualization because you could highlight. You know. The focus should be on the data itself, not on the decoration around it and the borders, etc. So you'll see mostly tables like this with very minimal borders. So people will focus on the numbers and less like this. Sometimes you could use colors for the numbers to highlight, let's say, an increase or a decrease. Those are called like heat maps. Um, pies are not, pie charts are not preferred because they're 3Ds in general. Also, they can make what's closer to you look bigger than what it actually is. 3D is also not recommended because, for example, here, if you take a look at first glance, some people may think this is the line because this is 1, so they may think January is actually higher than 1, but because this is 3D, actually the line goes like this. So it's unnecessary to make people think too much for a simple graph like this, or force a mistake of interpretation when it's completely unnecessary just because you want to make things look 3D or look nice. So these things I would avoid. But also avoid double axes, like 2 y-axes or 2 x-axes, because they complicate the story. Remember we said the goal is to simplify, not to over-complicate. And if you put too much text, then you're probably not telling, you're not creating a good or a simple enough graph. You could also, remove some clutter. Sometimes you can simplify, shorten month. In this example, you can put the legend next to it. Remove decimals. So you can do simple things to make your graph less cluttered. And then if you're creating a heat map, usually rule of thumb, if you have more than 2 color shades, then you have too much. So if you have, blue here, for example, going from white to blue, this makes sense because this is going the opposite. So the smaller the number, the darker, because it's like a rank. So darker number means higher ranking. They're ranked 1 and 2. But if I have 4 or 5 different colors, then it defeats the point because I don't know which color is which. It makes it very hard to follow. So for heat maps or shaded colors, 1 to 2 colors maximum. And when you look at this, 2 versions of the graph, you may like this one better, but actually white backgrounds or light backgrounds are preferred because they allow the user to look at the numbers first. For this graph, I bet you the first thing you notice was the black background, so it took your attention on the background, and that's not the point. The point is to highlight the numbers, not the decorations around it. So that's pretty much it for the theoretical part. You learn a good tool. If you're after your Lamborghini, you iterate, you get feedback from your colleagues, your team members, as we mentioned, see if they can understand the graph without you interpreting it, and then you iterate, continue to improve it. How to create these types of graphs, I'll show using the hands-on in a bit. So let's do the following. Before we take a break, I just want to remind you of the dataset you need to download. All right. Okay, so now it's 7:50, 7:51. Let's come back at 8:05, so 14 minutes. If you haven't already, download this dataset, blockchain clean, the clean, not the other one. This is the one we'll use now, and this is the clean version of this survey, as I mentioned. Download it, open Tableau, and then leave it open. Don't connect, don't do anything. I'll guide you through it step by step, and we'll go from there. All right, so let's come back at 8:05.